Hello everybody, this is Dr. Asha. I'll be discussing about the requirement and the necessity of the filtration of water in the water treatment process. As we all know that in the whole line of the treatment process, there are various treatment units which produces water of its own importance. While when we understand about the treatment process, screening and sedimentation can remove a large percentage of the suspended solids and organic matter present in raw water supplies. The percentage of removal of finer colloidal matter increases only when the coagulants are used before sedimentation. But however, the resultant water will not be that pure and they may even contain very finer suspended particles like they may be like discrete or flocculated when coagulation is used, and the bacteria are also will be there, and the removal of that becomes very important to remove or to reduce the remaining impurities, that is which includes the very finer particles and the microorganisms. The water is filtered through the beds of fine granular material such as sand, etc. The process of passing the water through the beds of such granular materials, what we call as filters here, is known as filtration. And the filtration may help in removing color, odor, turbidity, and pathogenic bacteria from the water. The bacterial content of water is considerably reduced due to the presence of an active zoological layer formed on the top of the filtering material, and that we name as the dirty skin or smoosh deck. Two types of filters are commonly used for treating municipal water supplies, and they are the slow sand gravity filters and the rapid sand gravity filters. The third type is the pressure filter. That is because like the rapid sand filter works under pressure, and henceforth the name is the pressure filter. This type of filters are generally used for small plants such as for individual industrial supplies or for swimming pools, and are generally not adapted for treating large scale municipal supplies. The slow sand gravity filters, often called as slow sand filters, are usual in the sense that they can remove much larger percentage of impurities because of the slower rate of filtration, and very importantly, the slower rate of filtration aids in the removal of bacteria present in the water as compared to that what could be removed by rapid gravity filters. However, the slow sand filters will yield a very slow rate of filtration, that is about 1/30th of that given by the rapid gravity filters, and the only disadvantage of this in comparison is the requirement of the larger area. With the advancement of disinfection techniques, the necessity of too much of purification from the filtration is becoming very decreased. That is because the rate of filtration achieved from the slow sand filters, even though it is very high, but the time constraint is there, and therefore the slow sand filters are becoming obsolete these days. And in the modern treatment plants, rapid gravity filters are nowadays mostly adopted globally, and the water from the coagulation sedimentation plant is directly fed into the rapid gravity filters, and the resultant supplies are disinfected for complete killing of germs and color removal. Since after the filtration, there would be another important task, that is the disinfection. It is not that much necessary for the complete removal of all the organisms. Therefore, usually we adopt rapid gravity filters for the filtration process. And before we discuss the theory and operation of the various types of filters in detail, it is worth to understand about the theory of filtration. The filters, in fact, purify the water under four different processes, and they could be summarized as mechanical straining, sedimentation, biological action, electrolytic action. That means to tell that when water is filtered through the bed of filter media, usually consisting of clean sand, the following actions takes place. And so we shall just get to know about all those individually. So first of all, if we are talking about mechanical straining, as the word itself indicates, it strains out all the suspended particles present in the water, especially which are of bigger size and than the size of the voids in the sand layers of the filter, which cannot pass through these voids and get arrested in them. The resultant water will therefore be free of them. Most of the particles are removed in the upper sand layers. The arrested particles, including the coagulated flocks, forms a mat on the top of the bed, and that mat will further helps in straining out the impurities. So here the formation of the mat is nothing but the impurities that is been arrested in the top layer. The next process is the flocculation and sedimentation. It has been found that the filters are able to remove even very smaller particles than the size of the voids present in the filter. And this fact may be explained by assuming that the void spaces act like tiny coagulation cum sedimentation tanks. The colloidal matter arrested in these voids is a gelatinous mass and therefore attract other finer particles. These finer particles will thus settle down in the voids and get removed. The next is the biological action. When a filter is put into commission and the raw water is passed through it, during the initial days, the upper layers of sand grains become coated with reddish brown sticky deposits of partially decomposed organic matter together with iron, manganese, aluminium, and silica. That is because they are the sand layers. I mean, the layer is formed from the selected sand. After some time, there exists in the uppermost layer a sand of upper layer of sand, a film of algae, bacteria, and protozoa, and that is the dirty skin or smooth stick. And this acts as an extremely fine mesh straining mat. The impurities will start collecting on that mat because the impurities in the water become food to different microorganisms residing in the filter beds. The bacteria not only break down the organic impurities and convert into harmless compounds but also destroy each other and maintain a proper ecosystem in that particular layer. In fact, this layer further helps in absorbing and straining out the impurity. The next one is the electrolytic action. The purifying action of the filter can also be explained by the theory of ionization. According to this theory, a filter helps in purifying the water by changing the chemical characteristics of water. And this is very easily understood by the fact that the sand grains of the filter media and the impurities in the water carry electric charges of opposite nature. When these oppositely charged particles and the impurities come in contact with each other, they neutralize each other. Thereby, they change the character of the water and making it purer. After a certain interval, the electrical charges of sand grains get exhausted and then they have to be restored by cleaning the filter. We shall understand about the features of the slow sand filter. By the term the slow sand filter, it means to tell the rate of filtration through this type of filter is very slow. That means there will be around 1/20th or less of the rate of filtration that undergoes in rapid gravity or pressure filters. This is because of low filtration rate. Slow sand filters require larger area of land and are very costlier to install. Therefore, it is been becoming obsolete these days of adopting slow sand filters. And in spite, we can just tell that their use has been decreased, and however, they may be still preferred on some plants at warmer places where covers on the filters are not required to protect the filters from freezing. Flow sand filters normally utilize the effluents from the plain sedimentation tanks and are used for relatively clearer water. The slow sand filter consists of the following parts mentioned below. They are the enclosure tank, under drainage, base materials, and filter media of sand. So here is the figure. We can just see that this central drain is being supported with the lateral drains on either sides. We shall now understand about the various parts of this slow sand filter. So here is an enclosure tank. It consists of an open watertight rectangular tank made of masonry or concrete. The bed slope is kept at about 1 in 100 towards the central drain. The depth of the tank may vary from 2.5 to 3.5 meter. The plan area of the tank may vary from 100 to 2000 meters square or even more, and that depends upon whether the quantity of water to be treated is high or less. Next is the filter media. The filter media consists of sand layers about 90 to 110 centimeter in depth and placed over a gravel support. We can see here that the sand is being supported with the gravel. The effective size D10 of the sand varies from zero point 0.2 to 0.4 mm, and the uniformity coefficient, that is D60 by D10, varies from 1.8 to 2.5 meter or even up to 3 meter. The top 15 centimeter layer of this sand is generally kept of very finer variety than that of the rest, which is generally kept uniform in the grain size. However, if the different gradations of sand are used, which is not necessary, then the coarsest layer should be placed near the bottom and the finest layer should be placed at the top layer. The finer the sand used, the purer will be the water obtained, as more impurities and bacteria will be removed in this top layer itself. Next is the base material. The base material is gravel and it supports the sand. This consists of 30 to 75 centimeter thick gravels of different sizes placed in layers. Generally, 3 to 4 layers each of 15 to 20 centimeter depth are used. That means to tell that each layer will contain around 15 to 20 centimeter depth of the gravel. The coarsest gravel is used in the bottom layer and the finer one will be in the top layer, which is generally kept around 40 to 65 mm, and in the intermediate layers, which vary between 20 to 40 mm and 60 to 20 mm when two intermediate layers are used. And the topmost layer will contain the finer materials or the finer gravels that will be around 3 to 6 mm. The next one is the under drainage system. The under drainage system, that means to tell that the gravel support is laid on the top of the under drainage system. The under drainage system consists of a central drain and the lateral drains as shown here in the figure. The laterals are open jointed pipe drains or some other kind of porous drains placed 3 to 5 centimeter apart on the bottom floor and sloping towards a main covered central drain. The laterals collect the filtered water and discharge it into the central drain, which further leads to the filtered water well. Sometimes it so happens like instead of placing in the central, the main drain is placed along one side of the tank and the laterals slope towards it. The next is the inlet and outlet arrangement, and we can just see here that the inlet arrangement is constructed for admitting the effluent from the previous treatment unit, that may be a plain sedimentation tank, without disturbing the sand layers of the filter and to distribute it uniformly over the filter bed. A filtered water well is also constructed and on the outside in order to collect the filtered water coming out from the main drain, that is a main under drain. In order to maintain a constant discharge through the filter, an adjustable telescope is being placed and it has been shown in here in the figure. The inlet and outlet arrangements are generally governed by automatic valves. Besides these arrangements made, certain other appurtenances are also provided for the efficient functioning of these filters. For example, vertical air pipe passing through the layer of sand may be provided and may help in proper functioning of the filtering of layers. Similarly, arrangements are even made in order to control the depth of the water level above the sand layer, that is around 1 to 1.5 meter, and this depth is not allowed to undergo long variations. In addition to this, a meter to measure the flow, a gauge to measure the loss of head are installed. The loss of head caused by the resistance offered by the sand grains to the flow of water through it is usually called the filtering head. It is the difference of water levels between the filter tank and the filtered water well. For a freshly cleaned filter unit, the resistance offered is usually less and therefore the filter head is usually small, that will be around 10 to 15 centimeter, but it goes on increasing as the filter layers get clogged and the telescopic tube is adjusted by manual labor. This is to maintain a uniform discharge, but when this loss of head becomes higher than 0.7 to 1.2 meter or even more, the filter unit must be put out of the service and be cleaned. Now here we shall understand about the cleaning operation of a slow sand filter. As the process of filtration goes on, the filtering media gets clogged due to the impurities adhered to those sand particles, and the loss of it will go on increasing gradually. When the loss of it reaches certain limit, the working of filter will be stopped, and at that time the filter requires cleaning. So it may also be noted here that the water entering the slow sand filter should not be treated by coagulants. This is because the fact that the dirty skin or smooth deck formed by the flock is carried to the filter considerably, thereby affecting the economical working of the filter. The depth of water on the filter should also be decided carefully and it should not be allowed to undergo large variations. This depth decided should neither be too large nor it should be too small, and generally